Welcome back. Today we're getting into a piece of pretty much invisible tech, the kind of thing that makes or breaks your cable signal in really big buildings.
We're talking about the Thor Broadcast H-RF-AMP-40. And I know the name sounds like a page from a technical manual.
It really does. A 40 dB bi-directional distribution amplifier.
But this thing is basically the engine room for video distribution. Think apartment complexes, MDUs, or just massive cable TV networks.
So our mission today is to break down why this specific piece of gear is so absolutely essential for getting a clean signal out to hundreds of TVs.
Okay, so let's just imagine the problem. You have a huge facility, like a hospital.
Or a resort, right? And you have miles of coaxial cable running all over the place.
Exactly. And over that distance, the signal naturally gets weaker. It just decays.
And that's where this little box comes in. It's built specifically to fight that decay.
It does that by handling this huge spectrum from 54 all the way to 8,000 megahertz. So that's basically channels 2 through 158.
And it boosts it with a massive 40 dB of gain. That sounds like a lot of power.
It is a lot of power. But, it's not just about the brute force. It's really about how clean that power is.
What do you mean by clean?
Well, the specs on this thing show an extremely low noise figure. It can be as low as 4.5 dB.
Okay, low noise. Why is that the critical part?
It's vital for a technique called amplifier cascading.
Cascading, like stacking them? Why can't you just use one enormous amplifier for the whole building?
Because the cable runs are just too long. Think about a university campus. You have to daisy chain multiple amplifiers to cover the distance.
And I'm guessing each amp adds its own little bit of noise into the system.
It does. It amplifies the signal, sure, but it also amplifies all the noise from the amp that came before it in the chain.
So it builds up.
Right. But by starting with a unit that's this low noise, system designers can string several of them together before that cumulative noise gets bad enough to, ruin the picture for the person at the very end of the line.
So it's powerful up to 60 dBmB output, but it's also really precise. And that lets it handle all the different video signals out there, from the new digital stuff like ATSC to older analog NTSC.
And we have to talk about the bidirectional part. That's what really separates modern amps from the old ones.
Right, it's not just a one-way street.
Not at all. It handles the forward path. That's the content, your TV channels, but it also handles the return path, which is 5 to 42 megahertz.
And that's for all the interactive services,
Yeah.
Right? But hold on, you've got signals moving in two opposite directions on the same cable on different frequencies. Isn't that a recipe for interference?
It is a huge engineering challenge. That return path is absolutely necessary for any kind of upstream communication, like services that use CATV RF-QAM over coax.
So with all that complexity, how do they guarantee the picture and sound stay distortion-free? I saw mention of hybrid push-pull technology.
That's a big part of it, yeah. But for me, the most impressive spec is the flatness. It's plus or minus 0.5 dBm across the entire band.
Flatness. What does it actually mean for the technician in the field?
Well, imagine the signal spectrum is a mountain range. If it's really bumpy, a tech has to go and manually smooth out those peaks and valleys for every TV.
That sounds like a complete nightmare.
It is. This flatness means that landscape is already almost perfectly level. It saves a staggering amount of time and money on equalization out in the field.
And these units, they have to be reliable. They're stuck in dusty wiring closets for years.
For sure. And that's why this thing is built like a tank. It has high voltage surge protection, even lightning protection built right in.
The enclosure is also shielded, right?
Over 95 dBs of RFI shielding. That's not just to stop outside interference from getting in. It also stops the amp signal from leaking out and messing with other sensitive equipment.
And for the poor tech who has to service it.
They made it easy. You've got adjustable gain and slope controls, and most importantly, these little next 20 dBb test ports, so you can check the signal health without having to disconnect everything and take the whole system down.
So when you boil it all down, this is really the silent guardian of the whole system.
That's a perfect way to put it. It just sits in a closet and works, making sure every single endpoint gets a pristine signal.
It's so easy to just focus on the TV screen and the content, but the real complexity is in the infrastructure you never even see.
Exactly.
So here's a final thought for you to chew on. Next time you're in a big resort or a modern hospital, just stop and consider the incredible, complex web of coaxial cable running through the walls and ceilings.
We're talking hundreds of thousands of feet of it.
And the video experience for every single person in that building, the customer satisfaction, the profitability, it all hinges on the flawless 24 and 47 performance of one of these simple, rugged boxes. The failure of just one could take down service for hundreds of rooms.